Hello friends, welcome back to the bench. Our patient today is this relatively old, a little on the older side, MSI Z170A PC mate. The exact model is 7971. This is revision 7971 version 2.1. And we have a schematic for it, or sorry, the board view. I don't think I have a schematic for it, but honestly, on the motherboards, I find that schematics are not super necessary. I mean, board view is enough. On laptop boards, they're always kind of customized and always kind of different. Schematic is very useful, but on these, they all kind of work the same. So as long as you have the board view, especially if you have a good board view, which tells you exactly what component is installed and all the nets are labeled, it's a lot easier. But even if you have the base schematic with almost no markings, it's still a lot easier, especially to figure out which chip is going to be turning on the power, which chip is responsible for the LEDs. And this one does have diagnostics LEDs on it, so the procedure is the same as every board. We will start with power, and as you can see, I already have the CPU installed and VIO with question mark. So this is the CPU I was testing the previous board with, which I still can't figure out what is wrong with it. But I have an idea. So remember when I connected 12 volts to the V core and high transistor was shorted, which means that 12 volts went through the coil directly to the CPU, to the VIO. So I'm thinking if the VIO is shorted here on the CPU, and unfortunately I can't confirm that right now because I'm still waiting for replacement CPUs, but if the VIO is shorted, that would explain why the other board turns on and turns off. And even though I don't see the current sensing resistor, there's another way the board or SIO can assess whether there's an abnormal current draw via timing. How long does it take from 0 volts to 1.2 or 1.4 to be reached? If the time is too long, that means we're grabbing too much power and it turns off. It could make sense. So this test will also hopefully eliminate the issue with the CPU. So connected without vCore, turn it on, turn on the board, board turns on, CPU is lit up. So far so good. Turn it off, connect the vCore. So if now the board doesn't turn on or it turns on and off, it's most likely our VIO is shorted on the CPU. And turn it on. And CPU went off and RAM is lighting up now. The CPU, I don't feel it getting warm, at least not yet, but it should start getting slightly warm. So good chance is that our CPU is good, which is too bad because the faulty CPU would explain what's wrong with the other board. Because if the CPU is good and I'm waiting for CPU replacement, once I receive it and the board behaves the same, then I still don't know what's wrong with it. It's a really tricky thing. And is this the right orientation? It is. So let's connect some RAM and see what happens. So now we expect that the RAM is gonna go off and it's gonna either flash VGA, well, not necessarily, because we do have the internal display adapter. So I don't know, let's see. It still turns off, and this is curious. So now it's still let's see if I can give you a close-up. So what happens is the RAM is still lighting up, but the board reboots. So as it goes to RAM, the board reboots. So that could mean that we have missing voltage on the memory. That would explain it. So let's check the board view, and our memory is supplied by this choke right here, and it's controlled by these two transistors over here, and that's our control chip. So if I measure here, I should have 1.2 volts. As you can see, this is before the choke, right? So you know, it's kind of counterintuitive, but I can't connect to anything here because these are big polymer or electrolytic capacitors that are through hole. So I would have to measure on the back side. So this will be easier. I'm just gonna connect to this is source, most likely. This is drain, most likely. So this is, yes, 5, and yeah, so this needs to be the drain, this needs to be the source. So if I measure on the source of Q32, I should see 1.2 volts. And it's exactly 1.2, well, almost exactly, but I don't know, considering. Yeah, so we do have memory voltage, and it's flashing. So let's check the voltage on the battery. 2.966. Oh, 2.3, 2.4. Why is it fluctuating like that? Yeah, well, the battery is definitely done. The battery needs to be replaced. But would this be the battery issue? I don't think so. What I need to confirm now is that our BIOS is being at least trying to be loaded. Because if we're trying to load the BIOS, that could mean that if BIOS will require memory, right? Because you gotta load that code somewhere. It's 16 megabytes. Well, not all of that is the code, but I imagine you need to load the entire image to memory. The CPUs don't have 16 megabyte cache, or at least not this one. Or, you know, internal operational memory is not as big to allow the entire BIOS to be loaded, so the memory is required. So if the memory is not present, or there's an issue with memory, then the BIOS won't load, because it has nowhere to load. That also could mean that our PCH is faulty, because we connect directly to PCH with our SPI. So what I want to see, because checking on the PCI MOSI or MISO, that's not gonna necessarily tell you anything, because that's a shared bus. So the signal is only relevant if our CS pin changes. I think it's high by default, and to wake up the chip, to tell the chip that I'm talking to you right now, the CS goes low. Or the other way around, I actually don't remember. It's not relevant, because what we want to see is on this pin, we want to see some signal. So that's the third one from the left. There. And now when we turn it on, we want to see that CS is going up and down. It's up. That is correct. So the chip is not talking. But once we turn on the board, and there it was, yeah. So we're trying to load the BIOS. Definitely. Yeah, and it keeps going in circle. So I think the only thing that we can do at the moment is to assume that the BIOS is corrupted, and that's what's causing the issue. And the main reason is that the voltage is not missing. The board turns on. It appears to be electrically working. I do have a BIOS for this board, and the great thing about these boards is that you can clip on. You don't have to remove the chip off the board. That's a great thing, because it saves a lot of time. See? Boom, and it's connected. Let's get the Neo programmer. Alright, so we have our chip. So I already backed it up. So I'm just gonna erase the chip and upload the BIOS that I downloaded from the MSI website. Alrighty, we are updated. So now the question is there going to be a difference? It's 50-50, because it still could be the CPU. Because SIO, I assume, that is crucial for the peripherals, right? So if the SIO or VIO is shorted on the CPU, that would explain why we can't connect to the memory despite voltage being correct. Let's start it up and let's see if it's gonna explode. Almost exact same behavior. Now it seems to be flashing a little faster. So has it been a BIOS issue? It could have been on top of faulty CPU. But this is where we have to stop, because we have no replacement CPU. It's warming up nicely. properly. It's not overheating. Nothing else here is getting hot. Oh, this is getting hot. This is, I think, SIO. We can check on the schematic, but yeah, we basically, well, we do pass the CPU and we get stuck on RAM and reboot. I think this could be explained by faulty CPU. So unfortunately, we have to wait patiently until we receive the CPUs. This time I ordered few of them, and I even found a better price, like $8 per CPU. These are old 6th or even 5th generation, 4th generation. So old CPUs, i3, but perfect for testing. Maybe you wouldn't build a rig on them, but for testing, absolutely perfect. And at least you don't feel bad if this one turns out that I fried it with 12 volts, and I'm pretty sure I did, because that would explain a lot of issues I've been having. And at least you don't feel bad. $6, $8, up to $10. Well, I don't think this was super helpful, but at least we have a direction where we want to go with this. And if the CPU is indeed faulty, that's going to be great news, because that's going to fix 2 boards. Alrighty guys, thank you very much for watching, and I shall see you in the next one.